Hello everyone, welcome back to our channel RADIATIC. Today we will see unit convergence. This is the second lecture of unit convergence. In this lecture we will see about Curie to Becquerel conversion. How Curie is converted into Becquerel. Both are the unit of activity. In that previous lecture, lecture first of unit convergence, we had already seen the Röntgen to Gray convergence. So let's start how Curie is converted into Becquerel. You know very well 1 Curie is equals to 3.7 into 10 to the power 10 Becquerel. You know why this value come? Why not 10 to the power 10 only or 10 to the power 12 or any other values? Why this much value only came 3.7 into 10 to the power 10? Is this random? No, it's come from pure physics. Let's understand how it came. It's not a formula, not a definition. It is a measurement from nature. This value is not defined by human. It is measured from real radioactive elements. And once you see this, you will never forget how the value came. 1 Curie is equals to 3.7 into 10 to the power 10 becquerels. Okay, and you know very well 1 becquerel is equals to 1 disintegration per seconds, and 1 Curie is based on real material, that is radium. So 1 Curie is equals to activity of 1 gram of radium, that having mass 226. We first calculate the number of atoms. To calculating number of atoms present in 1 gram of radium, we have to know that the atomic mass of radium, that is 226 gram per moles, and the Avogadro number. The Avogadro number is 6.022 into 10 to the power 23 atoms per mole. Using these two values, we will get how much atoms present in 1 gram of radium, that is n. N is that number of atoms. So finding number of atoms, we have to divide the Avogadro number by the atomic mass of radium. So we get 2.665 into 10 to the power 21, that is number of atoms present in 1 gram of radium. Next, we need to know how fast these atoms decay. So the half-life of radium is about 1600 years. Now we find the decay constant, that is lambda. So lambda is equals to 0.693. This is the value of log 2 will be divided by T half. T half, that means the half life. The half life of radium is about 1600 years. Now converted into it into seconds, we got that the half life will be 5.05 into 10 power 10 seconds. So lambda is 1.37 into 10 power minus 11 per seconds. So the decay constant is 1.37 into 10 to the power minus 11 per second. Now we will find the activity of 1 gram of radium source. So the activity is equals to lambda n. Lambda is that decay constant, it showing the decay behavior of the materials, and n is that number of atoms. So activity is equals to 1.37 into 10 power minus 11. This is the value of lambda, and into 2.665 into 10 to power 21. This is the value of n. Now the value we got from lambda and n, substituting, we got the activity, that is about 3.7 in 10 to power 10 becquerel or disintegration per second. This is the activity of 1 gram of radium. So we says that 1 Curie is equals to 3.7 into 10 power 10 becquerel. So we got the value of Curie. This is not from randoms, this comes from the activity of 1 gram of radiums. Okay, so Curie is the historical units. 1 Curie is equals to how much we got? 3.7 into 10 power 10 becquerels. 1 Curie is also equals to 37 gigabecquerels, and becquerel is the SI unit of activity. Okay, 1 Becquerel is also equals to 1 disintegration per second. Now we understand how 1 Curie is equals to 3.7 into 10 power 10 Becquerel. Okay, this is the activity of 1 gram of radium source. So that this value not come from randoms, this is comes from the real measurement. Okay, so thank you so much. We will see next videos on unit conversion in next lectures.